All right, so next we're going to look at example 3. In example 3, um, so example 3 refers to the diagram we're just looking at. It says in the diagram above, not drawn to scale, O is the center of the circle. BE and DG intersect at O. Angle BOD is 135 degrees. We're to calculate, given a reason for each step of your solution, the size of angle BED, angle ODB, angle GBA, and angle GFE. All right, so these are the angles that we want to calculate. So the angles are BED 1, 2, 3, 4. Angle BED, and we have identified that in the diagram as angle 1. It's angle BDE. The next angle is angle ODB, angle ODB, ODB. We have identified that as angle 2. Angle GBA, we have identified that as angle 3. And angle GFE, we have identified that as angle 4. So let's start off with angle 1. Angle BED, which is angle 1, is actually equal to 135 degrees divided by 2. This is 67.5 degrees. Now, the angle at center is equal to 2 times angle at circumference. All right, so if you look, you can see that you have angle BOD and you have angle BED. Both start at B and end at D, but one goes to the what? Center, BOD, that goes to the center. The other goes to the circumference, BED. So they both start at B, end at D. One goes to the center, the other goes to the circumference. The one that goes to the circumference is called the angle at the circumference. The one that goes to the center is called the angle at the center. And the angle at the center, which is 135 degrees, is 2 times the angle at the circumference. So the angle at the circumference, angle BED, which is identified as angle 1, is equal to 67.5 degrees. Next, we need ODB, which is identified as angle 2. Now, OD and OB are both radius. That makes triangle BOD an isosceles triangle. So these two angles are equal, the two base angles are equal. So this angle, angle ODB, would be equal to 180 minus 135 divide by 2. This is 45 over 2. This is 22.5 degrees. And this is because these are base angles of an isosceles triangle. Base angles of an isosceles triangle. Next, so we found 1 and 2. All right, so let's try and put them in. 1 is 67.5. 2 is 22.5. This is an And that triangle is an isosceles triangle. So now we're at 3. Now, angle GBA, which is angle 3, is actually equal to 22.5 degrees. And this is the reason the angle between tangent and chord is equal to angle in alternate segment. So the angle at 3 is also 22.5 degrees. This angle here is 22.5 degrees. All right, because the angle between the tangent and chord at the point of contact B is equal to the angle in the alternate segment. All right, and this now brings us to the last bit, angle GFE. We need angle GFE. All right, this one will take a little bit more work. Let's see if we can find ways to make it easy for ourselves. GFE. All right, so we need to find angle 4. And to find angle 4, I'm going to use the fact that this quadrilateral here that this is a cyclic quadrilateral. All right, apparently it's not giving me the option to. It probably don't recognize this type of quadrilateral. I'm going to use the fact that this is a cyclic quadrilateral. All right, that's one. Now, and the fact that opposite angles in a cyclic quadrilateral are equal. So if I can find this angle here, I can find these two angles because opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. Guys, you see that entire angle at D, angle D, BDE, that's 90 degrees. And it's 90 degrees because angle BDE is an angle in a semicircle. So I need space to write all of that. So I'm going to tell the examiner angle BDE is equal to 90 degrees. It's an angle in a semicircle. The angle in a semicircle adds up to 90 degrees. Then I'm going to find, all right, this thing's a little annoying, but let's try and just work with it as best as we can. Then I'm going to find this angle here, which should be 67.5, I think. Is it 67.5? 67.5, yeah. This is 67.5. I could say that it's angle GDE. Then I could say angle GDE is equal to 90 minus 22.5. This is 67.5 degrees. Now, so this angle is 67.5. Now the angle I want, which is number 4, those two angles are supplementary. They add up to 180 degrees because they are opposite angles of a cyclic quadrilateral. So angle GFE, angle GFE is equal to 180 minus 67.5. This is what? 100 and what? 100 and what? 12.5? 0.5 degrees. These are opposite angles in a cyclic quadrilateral. And opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. All right, example 4 says, in the diagram below not drawn to scale, ABC is a tangent to the circle at B. Angle ABE, EBD, GEF are 77, 75, and 100 degrees respectively. So it's 100. All right. I have 110. I'm guessing it should have been 100 because it says, the question says 100 degree. Or should we just write 110 and done? All right, let's change it from here and keep what is in the diagram. So this is 110 degrees. All right, so we'll go back to a diagram now. Now, in our diagram now, we're asked to calculate the size of each of the following angles, given reasons for your answer. We need angle BDE. So BDE, that's the angle we indicate in the diagram as A. Angle GBE in the diagram, I indicate that as B. And angle EGB in the diagram, we indicate that as C. So we need to find A, B, and C in the diagrams. Guys, if you look carefully, you can see that if this is a chord, looking at that triangle, all right, that the angle here, which is the 77 degrees, is the angle between the tangent and the chord. And that angle is equal to the angle in the alternate segment. So angle BDE, which is A, is equal to 77 degrees because the angle between tangent and chord is equal to angle in alternate segment. So the angle at A is 77 degrees. Next, we need to find the angle at B. All right, so let's change up this a little just to answer that. Now the angle at B, to find the angle at B, you have to recognize that this shape is a cyclic quadrilateral. That's a cyclic quadrilateral. And the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So the 75 plus the B is the opposite interior angle. B is what we want to find. B is angle EGB. So if I want, I could tell the examiner that GBD angle GBD is equal to 110 degrees. The exterior angle cyclic quadrilateral is equal to the opposite interior angle. All right. So the entire angle, which is the 75 plus B, the angle that we want, is equal to 110. So angle GBE would be equal to the 110 minus 75 degrees. So when you subtract now, how much you get? 110 minus 75 degree, that is what, 35 degrees? This is 35 degrees. The angle at B is 35 degrees. Now, to find now the angle at C, which is angle EGB, which is the angle at C, is to recognize that these are opposite angles in a cyclic quadrilateral. And opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees. The angle at A is 77. So angle EGB is equal to 180 minus 77. This is equal to 103 degrees. They are opposite angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are supplementary. They add up to 180 degrees.